So good afternoon, guys. Again, this is the third segment, and hopefully we're starting to see the light. So today, what are we doing? We're doing how do we calculate area of a kite? How do we calculate area of a rhombus? How do we calculate area of a circle? And lastly, we're going to do how we calculate area of a semicircle. So example one here is a rhombus, and we ask for the area of that. So we have a rhombus, it's A, B, C, D, and we're given the distance from right at the corner of D of A to the middle of the rhombus, which is 15 centimeters, and we're given the distance from right at the corner of C to the middle of the rhombus, which is the 8 centimeters, right? So how do we find area of this? So area of a rhombus, remember, it's a half diagonal 1 multiplied by diagonal 2. Right? You can just write them as D1, D2. So remember, this distance is the same as that distance. So diagonal AD is equal to twice of 15, which is 30 centimeters. Right? Remember, the properties of a rhombus says that the diagonal and the other diagonal, they'll intersect right in the middle, that you have this line equal to that line. And so this diagonal as well, CD, will be twice the distance from C until the middle there, which is 8, and twice of that is just 16 centimeters. So we have the diagonals, we just need to substitute it here. It's going to be a half. Diagonal 1, called the AD one, 30, and diagonal 2, let's call it the CB one. This is CB, right? And that's 16. And if you multiply this through, half of 30, or half of 16 is 8. 8 multiplied by 30 is that's 240 centimeters square. So there we go, 240 centimeters square. Right? That's rhombus, example 1. Example 2, let's look at how do we calculate for a kite. We're given, there's our kite. A, B, C, D. That's the diagonal of AC. We're not given the whole diagonal. Diagonal of BD. We're also not given the whole diagonal. But for some reason, we're given the distance from there to the middle, which is 4 centimeters. Right? And then for another dimension we're given is the 5 centimeters, the AB there. And another dimension that we're given is the 7 centimeters there. Yeah, we're not given anything else. So remember what we need. We need this diagonal and this whole diagonal to calculate the area of this kite. So think about it. This diagonal, the distance there, getting there to the middle, will be the same as the distance from D to the middle, right? So diagonal BD is just twice 4 centimeters. The 4 centimeters I'm giving up there, twice 4 centimeters is just 8 centimeters, right? But how are we gonna find the distance from A right until here, the middle? How are we going to find it? Think about it for a second. If this forms a right angle, then voila, we have a right angle triangle in there. So if I take it out, it looks something like this. A is there, right? That's a right angle. And we're looking for this distance. I'll call it X. We're given this 5 centimeters and we're given this 4 centimeters. So I need to find that X value using Pythagoras. So if I apply Pythagoras on that, it will be 5 squared, right, equal to 4 squared plus x squared. 5 squared is 25. 4 squared is 16. I bring it to the other side. It's 25 minus 16 will give me x squared. 25 minus 16 just gives us 9. And so x squared is equal to just 3. Well, x is equal to just 3, right? So now we have the distance there. So that the diagonal AC is equal to 3 centimeters plus the 7 centimeters there, which is 10 centimeters. And so the area will be equal to half of diagonal 1 multiplied by diagonal 2. And diagonal 1, you can call that diagonal 1 half of 8 centimeters multiplied by 10 centimeters. And half of 10 gives us 5. 5 times 8 gives us 40. So we have 40 centimeters squared. So there we go. Let me just run you through it. Remember the formula for rhombus and kite. It's always half of the diagonal 1 multiplied by diagonal 2. Same for kite, half of the diagonal 1 multiplied by diagonal 2. Here all we needed to do is realize that that makes a right angle triangle, right? Take it out, put it there, visualize it, put the units there, solve for Pythagoras there. Once we're done solving for Pythagoras, have the x value there. Add the x value, which is this value here, with the 7 centimeters to get the 10 centimeters. And then that will give me the AC diagonal. So you just multiply it there and you find area. So this is just the kite and the rhombus. Let's do example 3 and 4 on the circle. Alright, so the circles